afternoon, good evening, good gracious. We're just getting the couple of people joining us now, and we're about to start with the BCH developer meeting number 9, and this is the last BCH developer meeting before the upgrade taking place on May the 15th. Undoubtedly, there'll be lots happening prior to the upgrade on May the 15th, but we are starting. I'm going to give you a quick overview of the agenda, and then I'm going to get everyone to do their introductions. We'll do the introductions first, then we're going to have status of the various node implementations regarding their upgrade readiness, as we've been discussing for the last meetings coming up to now. So we'll be hearing from BitcoinABC, BCHD, Bitcoin Unlimited. Unfortunately, we don't have a rep here, but they've made some progress as well. BitPrim won't be here, and AlwaysAnOn is here to talk a little bit about what's happening with BCash and the purse interaction. The third item on the agenda will be QUIC, networking protocol, and I'll get one of you to give a description and introduction of that, probably Antony. And the fourth item will be BIP 157, 158. I won't go into the details. We'll let you go through that. And we are going to remind the attendees that you're in a position to ask questions at any point using the Q&A function on the bottom of your screen. So feel free to ask questions at any time. We'll probably deal with the questions towards the end of the meeting, and I've got that as item number 5 on the agenda. So without any further ado, I'll get Jason B. Cox to introduce himself.
Sure. Hi, I'm Jason Cox, a software engineer contributing to BitcoinABC.
Okay, thank you, Jason. Antony Zegers.
Yeah, I'm Antony Zegers, also known as Mangarian, and I work on mostly BitcoinABC also.
Okay, thank you. Mark Lundeberg.
Hi, I'm Mark Lundeberg. I am a sort of independent Bitcoin Cash developer. Not really working on anything particular right now, various things.
Okay, he says that with a smile on his face. That's good. Next on my list is Josh Ellithorpe.
Yeah, I'm Josh Ellithorpe, otherwise known as ZQuestZ. I work on BCHD with Chris Pacia, as well as a number of other BCH projects.
All right, thank you, Josh. Amaury Sechet.
Hello, I'm Amaury Sechet. I'm the lead dev of BitcoinABC.
Okay, your mic is a little bit low, so maybe we'll get you to speak up when it's time to talk. And the next on my list is the guy with the great hair, Emil Oldenburg.
Hi, my name is Emil Oldenburg. I'm the CTO of BitcoinABC. Currently, we're focusing a lot on the BitcoinABC mobile wallet, and which is going to have a very, very nice, interesting update very soon. Other than that, sometimes I do patches for BitcoinABC that we use internally, and in hopes of one day merging it upstream.
Great, thank you, Emil. The next on our list, and the final on the list right now, is AlwaysAnOn. Could you do a quick introduction?
Hey everyone, AlwaysAnOn here. I work on various projects on BCH. Right now I'm trying to get BCash ready for the fork, which is what I'm here to talk about today, I believe.
Yes.
Yeah,
excellent.
And that's it.
All right, great. Thank you very much, AlwaysAnOn. We'll start off with the status of the various node implementations regarding the upgrade readiness. First on the list is BitcoinABC. Which one of you wants to take that? You ready? Jason, Amaury?
Well,
Yeah, ready.
there is nothing new.
Yeah,
Like, I mean, we've been ready for the upgrade for like almost 3 months now.
Okay. Anybody have any questions for BitcoinABC about how damned ready they are? No. Not sure that was a very technical explanation, but being ready, I guess, is really what this part is about. BCHD, how about you, Josh?
So yeah, BCHD is ready. We found a few small issues on Testnet which was really nice. Thank you guys for bringing up the test network so that we could make sure that everything was ready for the upgrade. We had to make a couple of minor changes, but those have been available for some time now. We highly advise everybody to be using our latest release when it comes to the fork, which is 0.14.3. Yeah, we're all set.
Excellent. Okay, any questions for Josh? Not hearing. Okay. No questions are good questions. Anybody want to speak to Bitcoin Unlimited's release? I know that Andrea Susani could not make it today.
So I know that 0.16 is like 1.16 is supposed to work. 1.6, I mean. So Bitcoin Unlimited, it looks like they're ready, but I don't know about what the testing was. Does anybody that was working on the testnet know whether or not that was actually on testnet?
Yeah, I can talk about that. Yeah, they did test it on the testnet, and we did like an activation and all that, and the reorg through the activation point and tested all the new features and all that. So yeah, it looks like the BU release is working, and it was all tested out, so that was good.
Yeah, they also added a PPA for Ubuntu. There's Docker images available, so I think that it should be pretty easy. And I believe that 1.6 now has actually more nodes up than their 1.5.x release. So it looks like people are adopting it quite quickly.
Okay. Good. Anybody have an update on what's happening with BitPrim?
I guess I'm vaguely aware. Also, just the same thing. Like they have a release out that implements the upgrade, and they tested it on the testnet as well at the same time as the BU that I mentioned. So it seems to be working as well. So
excellent.
They're all ready to go.
Okay, thank you. Next on our list is BCash. AlwaysAnOn, can you give us your report then, please?
Yeah, so we managed to get BCash synced to the Snore testnet, made it to the tip. I'm working on getting it thoroughly tested so that I have the confidence to release it and say it's safe to go. I looked over the video, one of the previous videos in which Amaury and I believe it was just Amaury and Jonathan Gonzalez were talking about what testing requirements what cases to test for. One of the things that Amaury seemed concerned about, and Amaury, feel free to jump in if you want to add some clarification, was the network behavior with respect to not dropping nodes like while it's in the middle of activating the upgrade. And so while I have added a single test to make sure that the upgrade activates at the correct time, I haven't done the testing for the network behavior and making sure that we don't drop peers when we shouldn't and that we do when we should, and haven't added any tests for the mempool, none of that stuff yet. I'm working on it, but I can only go so fast. So I'm kind of hoping Jonathan or someone else wants to step in and help so that we can make this thing happen make it happen in time, but not counting on any of this. I'm going to continue full steam ahead and hopefully get it ready in time.
Okay, talked to Mark Tynaway just briefly. He felt optimistic that there was a good possibility that it would be on. So that was good. Amaury, did you want to add anything to AlwaysAnOn's report? No? Okay. All right, so he didn't jump in. I guess that's good. Any other questions for AlwaysAnOn regarding the BCash implementation? Hearing none, we will be prepared to move on to the next item on the agenda. QUIC. Antony, I'm going to let you lead this off, if you would, because or do you want Amaury to do it?
Well, I mean, I can give a brief intro. I think someone else, I know Amaury and but Chris Pacia is not here today because he was interested in it. I don't know if Josh knows about it a lot.
Yeah, I'm very familiar with the protocol.
Oh, okay. Well, maybe all I really know is that it's like it's a protocol on top of UDP that Google developed, and it seems like a good thing to use. Beyond that, I don't know much. I don't know like the specifics. So yeah, that's all I really know. I know that Google uses it for all their Google services. Is my understanding. So I think it's a pretty well known protocol, and seems like the kind of thing that's better than what the current networking is in our node implement.
So it is slightly better than the current networking technologies that we're using for the nodes today, but a lot of those improvements are around the initial handshake latencies, and those don't really affect us as we have persistent connections. So the way that our connections work are going to be fundamentally different than like a web server that takes a short-lived connection, where the connection creation and teardown actually matters speed-wise. And for us, since we have persistent connections between the nodes, that benefit in the initial handshake really isn't as beneficial for us. But it also includes an encryption spec as part of the protocol, so it would allow for some level of encrypted transport between the nodes, which means that it would be more difficult for an attacker to like eavesdrop on the entire network. They would actually have to bring nodes onto the network in order to intercept data, where today everything is sent over clear text.
Yeah, there are. So it's true that the initial connection time is not really a concern for us because we keep connection open. But there are other improvements that we benefit from. One of them is so we have a traffic on the network that is a bit weird because it's very spiky, right? So most of the time we don't transmit that much data. And suddenly we want to transmit a large amount of data as fast as possible. And the way TCP works is by using a window. So the window is going to be, okay, I'm sending a certain number of packets to the person that deals with it. Is that better?
Yes.
Yes, okay.
Something about losing packets, ironically.
Yes. So yeah, the way TCP works is that you send a certain number of packets and then you wait for the person at the other side to acknowledge that it has received the packet. And if this process happens successfully several times in a row, then the number of packets that you send before waiting for an acknowledgement is increased, right? And what happens is that at the beginning, when you start transmitting, you transmit very slowly because you spend most of your time waiting for the person at the other end to acknowledge. And only once you've transmitted a certain amount of data, you actually are going full steam ahead. The problem that we have is because our workload is typically very spiky, we never reach that stage. And so even if you have like a 10 gigabit internet connection, you don't transmit stuff any faster due to the way it works in TCP. So that's one of the problems. Another problem that we have is head-of-line blocking. So head-of-line blocking is when you have a protocol where you send requests and then you wait for responses and then you send requests again. You might find yourself where you make a big request that takes some time, but in the meantime, you have another request that you would like to make, and this other request is blocked. Particularly, it happens on the web as well. On the web, it would be, for instance, you are loading your web pages, and there are various assets on the web page, right? There are styles, there are fonts, there are images, there is text and stuff like that. And maybe you are stuck downloading one of the big images on the website, and there are many of smaller assets that you could be downloading, like style sheet or fonts or whatever, that could improve the look and feel of the website right away, but they are blocked behind that big images. And the way web server typically solve that is by opening several connections, but that's not very practical for us. And for us, we end up having similar issue where we have some packets that are very latency sensitive. For instance, transmitting blocks. It's something that needs to happen as fast as possible. And so we don't want to be waiting for other communication with the other node to finish before we start sending the block to the other node. And this is something that QUIC can help with as well, because it supports several streams within a connection. So those are really the two, the two main points that are a bit different from what is most interesting for the web, but that's interesting for us.
Yeah. So if people watching this want to read more on that, it's really around being able to have multiplex connections that are more efficient, as well as the, what was the word that I was looking for? As well as, sorry about that, the improved congestion control, because it has better congestion control options, which allow for us to stream faster data. And those are probably the benefits that we would get out of QUIC. And it actually wouldn't be that difficult to implement.
So that ties into the two questions that were on the agenda, which is why would we want this in Bitcoin Cash, and what amount of effort is required to implement using it?
So I can jump in there as well. The amount of effort is actually a bit larger than what you'd expect, because we cannot reuse what is built for the web right now. So right now, like 99% of usage of QUIC are for HTTP. And the thing is, they use TLS as an encryption method to build the tunnel, through which the connection is going. And TLS is not suitable for us at all, for many reasons. The main one being that it's set for a client-server communication type of thing. There is the whole certificate business that really don't make any sense in a peer-to-peer network. So that's one issue. The second issue is that it's come with a whole suite of ciphers and stuff like that. But we already have cryptography within our application, and if that cryptography is broken, we have much bigger problem than the encryption of the tunnel being, weaker. If like SecP 256K1, for instance, is broken for some reason, then we are in very, 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 problematic territory, and really we don't really care that someone can break the QUIC encryption at this point. So bringing like all those other encryption method like TLS would bring us only increase the attack surface for us. So what we actually would want to do is, instead of using TLS, using something maybe based on the noise protocol. So the noise protocol framework is a framework to build encryption and authentication protocols based on whatever primitive you want to use. And Lightning Network is using that, for instance, and I think it's much more sensible for the type of use case that we have. So we need to get some QUIC implementation, but then we need to strip out the whole TLS part of it and replace it with some noise implementation.
So maybe I'm not seeing something. So for TLS with client server, it's because you need to trust one of the endpoints, but we're in an untrusted connected environment with full nodes. So it seems to me that a no verify option on TLS, where you don't actually care about the root cert and you don't actually validate that, is actually absolutely fine for a multi-node environment. So, and then I'm not sure exactly what you mean by the exploit on TLS, as we're currently already doing things in plain text. What's the worst that can happen on that implementation on the encoding on the wire? I'm a little lost as to what the damage is there.
There is no damage per se. We just increase our attack surface for a good reason.
Okay.
Because that means we bring OpenSSL in. OpenSSL doesn't have a very good track record of being secure, to be honest.
Right.
And we bring like a ton of different cipher in, and any one of them being broken, there is like a negotiation phase in TLS about what kind of cipher I support. So if one of the cipher is broken, I can pretend that I only support that one, and then the encryption is broken.
But wouldn't that just leave to us being at the status quo where we're at today?
Yeah, but
I'm just curious.
Absolutely, but if we are going to change something, then it's better to change it for, like the best thing that we can change it for.
Oh, absolutely agree.
That is,
yeah, I was just thinking pessimistically. That's all.
yeah.
Okay. Any other discussion on QUIC?
Well, yeah, I just wanted to ask maybe Amaury, like my understanding was that part of the idea behind this is that because Avalanche requires authenticated communication between the nodes, and QUIC, I guess, provides that.
Mm-hmm.
It seemed like that was, and if we want to do QUIC anyway, because it's better than what we have.
Yes.
That's my understanding of like how the pieces all fit together. So I just wanted to confirm that makes sense. So I guess the idea is, if we want to have Avalanche later and we want, then we may, it makes sense to look at QUIC now beforehand as like a piece that will fit into that.
Yeah, so effectively another benefit that we get from using QUIC is that we have an authenticated tunnel to communicate, which means that anything we receive through that, we don't need to sign or do anything with to verify that it's correct. The fact that we can decrypt it means that the person at the other hand is the right person because it has the right key to encrypt it. And
does this mean that we can get rid of the redundant checksum for each packet?
Yeah, we probably want to keep some kind of checksum, but
yeah, but I'm talking about the very inefficient checksum that Satoshi.
Yeah, so that's an opportunity to change it as well, even though that's not strictly in the transport layer, but yeah, the way checksum are computed right now, I don't know if people are aware, but you compute a SHA-256 of the whole message, and then you take 32 bits of it, and you use that as a checksum, which you end up computing a very, very expensive cryptographic hash for zero cryptographic security. And it's just very expensive for no reason. And you need to run that over, anything that is sent through the wire. So it's not very good. And it's something we can change if we use if we build the second protocol. But the idea is that right now all the messages that we have are either expensive to produce, like blocks, or signed, like transactions. And for those types of messages, it would be very difficult to change them, and it's possible at the other end to detect that they have been changed. But if we want to extend the protocol using messages that don't have those properties, and this is the case for Avalanche, but this may be the case for various protocol extensions that we want to do in the future, the solution that we have right now would be to sign everything, right? So that the person at the other end can verify the signature and verify that it come from the right person and is not modified by someone in the middle. But that's a very inefficient process, and doing encryption at the transport layer and rely on that to make sure that what you receive comes from the right place and have not been modified is a much more efficient solution.
Does it make sense to have a dedicated meeting about it organized from within the work group? I'd be happy to share that if you want.
Maybe, but we're very far from having any kind of concrete spec for it. So
okay.
I'm not sure it makes a lot of sense to spend.
I have a feeling it's going to keep reoccurring on the agenda for discussion. So we'll just carry on in the next meeting, and then if there's a need, we can have a special meeting for it.
Yeah, I personally
don't want to talk about it too much. I mean, it's
okay. All right, then you won't be invited.
So the only issue that I have is that the QUIC implementations for different languages are going to have different implementation details. If we make a lot of changes based on the base QUIC spec that currently exists, that means that language bindings for different nodes are going to have a harder time implementing a compatible layer between each other. So I'm a little bit concerned about that with regards to BCHD and ABC compatibility. So I just want to make sure that the specs are very well written so that we know exactly what changes would need to be happening so that we can test that interoperability.
Yeah, so the only thing that we want to change is not QUIC itself. It's the uncheck at the beginning. So where you decide, the cryptographic key to use for the encryption and all of that. Right now, there are two implementations of that stuff. One is made by Google. It's called QUIC Crypto, and it's a protocol made by Google, but it's mostly deprecated now, and most of the QUIC traffic now is moving toward TLS. And we don't want to use the deprecated stuff, and we probably don't want to use TLS because it's not ideal for your use case. So this is that specific piece that we want to change, but everything else, we probably want to stick to the IETF spec.
Mm-hmm.
All right, we'll put up a link to the work group and see where we go from there. Any further discussion on QUIC? Hearing none, we'll move on to the fourth item on the agenda, which is BIP 157 and 158. Antony, do you want to lead this off again, please?
Well, I don't know too much about this.
Sorry.
I know that they've implemented it in BCHD and that Mark was working on putting it in ABC. So maybe either Josh or Mark might want to.
Thanks, Antony. Who wants to dive into this?
Yeah,
So
well,
I guess-
I'll let you with the BCHD.
Yeah, so BCHD has an implemented version of the spec. We did have to make a slight adjustment based on the spec that was finalized by Core, because in our testing, we realized that malicious nodes or nodes that disagree about the filters, there was no way to rectify that with the current Core spec, and we do not believe that that spec actually works. So we actually pulled in Jim Posen. He was the one that actually did the work for Core. We discussed the problems that we saw with the spec as it landed in Core, and we agreed with him on the changes that we made, which was basically instead of input script pub keys, we decided to use the out points. So that actually made it so that our Neutrino wallet and the existing implementation for Neutrino is actually fully functional. For a while, we were on training wheels where we're using hard-coded nodes, but we're actually on the live network now with different versions and some people running old versions that had different filters, and everything is actually working. I actually talked to Mark about the possibility of him helping me get that into ABC. And so I'll let him do the status updates there, but very close to my heart.
Maybe let's just quickly summarize what this BIP 157, 158 stuff is. Basically, it lets full nodes summarize in a compact way the items of interest that are in a block, so that wallets like Neutrino can download a much more compactified, compressed version of a block. It's basically 1% of the block size. And from that, they can figure out whether they want to download that block or not to find their transactions. So if you're familiar with like ideas like Bloom filters and that sort of thing, it's very closely related, but it's happening from the node side. The node is sending a Bloom filter in effect. It's a Golem filter, but it works very similarly. It sends it to the wallet, and then it's up to the wallet to decide whether it wants to get a transaction. And this is actually really nice for privacy. The wallet never sends a list of its addresses to the server that it's trying to find transactions from. And it also means that wallets can be sure that they're not missing any transactions, that the servers haven't omitted anything important from the blocks. And that's sort of a general problem with SPV wallets. That's a theoretical problem that in this case is being solved nicely. So yeah, I'm working on getting this patched into BitcoinABC. So Bitcoin Core just, I think, merged it in, I think, a week or two ago. And yeah, I think once it's all backported in, it should be fairly easy enough to make the changes that Josh was just talking about. And so
In fact, that was the original spec. Greg Maxwell had them change it at the last minute. So that is something that was already there, and it shouldn't be hard. I think it took Chris like an afternoon to switch it around to use the out points again.
Yeah. It should be easy. And but yeah, that'll mean if you're running the Neutrino wallet, your neutrino wallet will not just be able to connect to the BCHD nodes, which admittedly there are quite few, but you'll also be able to connect to these the BitcoinABC nodes and get your information from there. So that'll be pretty nice. Yeah.
I have item number D on the agenda suggests that, or ask the question, should a meeting specific to this topic be organized for more detailed discussion and design on the protocol? It's up to you guys.
I don't think that's necessary, as the stuff is based off of things that are well spec'd out,
Right.
and there's only one small modification that's well known by the developers implementing it. I've also had conversations with the BU devs to try to see if someone wants to spearhead also adding this to the Bitcoin Unlimited nodes. To date, I have not found that developer, but I figure that with ABC and BCHD supporting it, there would be plenty of nodes to make sure that we can have, non-RPC widely compatible wallets, and that would be good enough.
All right, that's great. Thank you.
I just have a question. Have anyone experienced any problems for Bitcoin J as an SPV wallet?
I have not used it.
Okay.
Anyone else have an answer for Emil? Emil, sorry.
What sort of problems are you worried about?
No, so the issue was that Neutrino was experiencing problems. Does anyone know if these problems also extend to Bitcoin J?
Oh, they use a very different backend, so they shouldn't be relevant. The neutrino bugs that we saw on these on the networks were because we couldn't validate which entity had the correct information based on the information the wallets had locally, and that's why we needed to go to something where the wallet actually had all of the data to know when it was being lied to.
Great. Okay, Josh, thank you for that. Anything further on bit 157 or 158, or have we exhausted that topic now?
Just one last thing is that there's a easy command line wallet. We ship BCH wallet, which is a command line wallet that is fully compatible with Neutrino. It's really useful for testing any implementations that are happening on the full node. And then we also have a developer preview of the Neutrino wallet for Android that also will reach out to the network. I also have a seeder, seed.bchd.cache, that has special filters to find neutrino compatible nodes. That's already live on the network, and that's what we're using for service discovery. So if you need more information about that, feel free to ping me on Twitter or find me online.
Great. Thank you, Josh.
So I have one last thing to add, kind of related to BIP 157 stuff. So one issue that Mark ran into was he had to backport a bunch of changes in order to introduce the change into ABC. And I would like to point out to everyone listening to this, like, if you have some time and you want to backport changes to ABC, that would help a ton with these sorts of changes in the future. Normally, this kind of delay would not be acceptable, but we have a lot of changes from core that we want to pull back in. So, any help there would be greatly appreciated.
Okay. Good. Thank you, Jason. For those watching, the planned network upgrade is taking place on May 15th. The Bitcoin Cash network will undergo a protocol upgrade as per the roadmap. Businesses and individuals who use the Bitcoin Cash network should check to ensure that their software is compatible with the upgrade. Compatible implementations are BitcoinABC 0.19.4, BCHD 0.14.2, BitPrim 0.19.0, and Bitcoin Unlimited 1.6.0.0. Work is also being done to get BCash ready as well. Thank you very much to the participants and the members of the audience, and to you, the viewers.